Hello and welcome back to the second part of the continuation of the chapter where we're discussing on creating the functionality for the lamppost. And I just realized that it's not going to take that long because at the moment what we need is a PCG graph as well as actor blueprint. But to start off, what we're going to do is to create a PCG lamppost first. So I'm going to go right click and search for PCG graph. Let's call it PCG lamppost. Double click on this and I'm going to add the necessary nodes to make sure that it works along this plan that we're going to then create it inside the actor blueprint. So let's search for get spline data, add spline sampler, transform points, and also in this case we are not going to use static mesh spawner but it's called spawn actor. And what's so cool about this node itself, it does allow you to use actors instead of static meshes. In other words, have more control by adding this actor into your settings that helps you to access some of the settings that actors possess. In this case, having some extra abilities that you've created inside your actor blueprint that we, let's say, created into, in this case, a lamppost asset. But because in this case, what we're going to do is to use this to spawn this actor we've just created and make sure it literally projects into our landscape. So I'm going to just connect all of these nodes together for now. And also what we're going to do is create these properties too, like we always do with parameters. I'm going to add 3 of them. Rename this to spawning distance. This is going to stay as a float. I'm going to also, in this case, search rotator because we're going to also switch the directions, specifically on the z-axis. Rename that, call rotate. And in this case, I'm going to rename this one as set to scale. Make sure you always set the values here. So I'm going to make sure distance is set to 100, also scale to 1. For now, you don't have to leave it as a rotation as it is. And I'm going to add those now. So I'm going to look for spawning distance. First of all, let me just change the mode to distance and make sure it's unbounded as always. Spawning distance needs to be connected to the distance increment. Minimize that. And let's add another nodes that we've just created. And this could be a rotate. And also scale. And first things, let's start with rotate. I'm going to connect this to rotation minimum as well as maximum. And with scale, we're going to set to minimum as well as maximum. Let me just make it a little bit bigger. And for the spawning actor, we're just going to add this lamppost that we just created. And I'm going to compile it. Now we can get into creating actor blueprint. So right click, create an actor blueprint, and let's call it lampposts. Drag into this space here. And let's start digging in. Let me double click. And let's go add spline first. PCG. And let's add our, in this case, lampposts graph instance here. So now we start getting something into our spline. But because we still have to configure a few things, so it's to make sure it works. But for now, we can test it, see what's happening. All of these meshes start to duplicate along the spline itself. But for now, let's just go and carry on with our exercise. I'm going to a construction script. First thing, let's go and access our PCG's components. In this case, variables. So I'm going to, as always, graph instance. Make sure you set to float parameter. Do it duplicated once more. I'm going to connect it one and again. And also I'm going to set the rotator. So I'm going to set rotator parameter. And let's put those names right. First will be scale. So always make sure that it matches the same names as this on our PCG graph. It's easier for me to navigate through. It's called spawning distance. And also it will be rotate, as I assume, right? Yeah, rotate. So let's start adding also our components that we need. So for this one, I'm going to add a few of them. For now, I'm going to, basically what we need to do is to exactly copy the same components that you already have in here. But because we're going to use this to expose them right there. So in this case, we're going to make sure naming is the same as this one and put them right there. So I'm going to use on and off lights. Intensity. Float. Attenuation radius. And emissive intensity. To make sure the name is right. Let's also add spawning distance and scale, and also add rotate. We are not going to set to rotators variable type. We are going to just use float. The reason why, because we're only going to use one axis for that. So we'll start working first on setting up our values here. So I always go start with 200. I'm going to make sure the minimum is set to, let's say, 200 to, let's say, 5,000. Let's do the same for value range here, and the same goes for the minimum, 200. Compile that. Scale should be 0.5, just like we always been doing it. 0.2, 5, 2, and keep it at 1 scale. And I think we're good to go here. I can just plug those in. Scale. I'm going to break this and split into struct, and I'm only going to use the UL value. Connect this all together. For now, we can just use it as it is. Compile that, and let's carry on. This is an important one because this one will require us to, in this case, lamp post that we are trying to access to. Because currently what's happening, we're only using one. So you can actually test it out this entire workflow. Let me just make sure I put them to be public. And I'm going to then expose it. So at the moment, you can test it out and see what happens, because currently we're not doing anything, obviously, because we are not being connecting it to our lamppost. So what I'm trying to say here is that every time you're only using this configuration, only we're going to work for one. So we want to make sure it works across all the lights that are available along this plane itself. So for this to happen, we have to set this as an array and access as an array of all these lamps that are being spawned. So to do this, I'm going first search for my actor that I already created. So I'm going to look for get all actors of class. I'm going to look for the lamppost. So bp underscore lamppost asset. I'll plug this into this. And what I'm going to do is to break it down into all the actors available. And to do this, we need to make sure we search it through the length of its array that is going to be allocated while all those lampposts are being, let's say, generated along this plan. And to do this, we need to do also reach all of these lamps through the for loop. So first things, I'm going to go search for length. That is going to search for all the available lampposts that are existing within the array. And we're going to for loop it all together to access all of them. So I'm going to make sure I'm connected to for loop. But it's going to be as a last index because we're starting from the 0 index. And the next thing I'm going to do is to make sure I'm also getting all these settings that I want to work with each lamppost. So this is where you need to do is to make sure you're getting all the essential configuration that's coming from the lamppost. And we are going to shuffle through as each index is reading to access all these lampposts all together. So once you take it out, then you can search for spotlight. The settings that we've created that comes from that lamppost asset itself. And I can go and loop this all together into this body thing. So because I already created these parameters, I can drag and drop into this, plugged it into that, just like as it matches the name itself. I'm gonna also do for the intensity. I'm gonna make sure they're all placed just next to each other. Also for the on and off lights. And emissive itself too. So now, if you place them all together just like that, I also want to make sure I don't make any mistakes there, so I'm going to compile all together. Last check. I got everything just as should be. Okay, perfect. So now let's go and test this out, see what's happening on the current configuration. If I set something to make sure it works, if I go increase my intensity, also I want to see if it also works for... Okay, I see that something's not working as it should be. Yes, there's one mistake I did, which I forgot to mention. Once you're on the spawn actor, you make sure you also match the PCG only. So that's the reason why it has to work with PCG. And you need to also allow to actor editing. It gives you more access to where you're dealing with, and compile that. So now it should be perfectly fine. So if we go test this out, so if I hit the G, key button, to visualize it, see what happens now. Now, as you can see, we start picking up our configuration. I'm going to also increase it. So if I go back to my editing mode and I'm going to drag it out so it's all visible. And just for the test, I'm going to also go back and turn off some of the lights we don't need. So I'm going to turn this off and this one off. Turn this one off and make a little bit tiny visible. Make sure we got this, and then we can start see what we can test it with. So if I go back again to my lamppost and start testing this out, so if I go and increase my intensity to something really high, then you start getting some results. So now as you start seeing my lights being on. So if I turn this off now, see what happens. The lights are starting being visible. And also what I can do is to change their rotation direction in this case. So I'm going to then go back to my lamppost and I set this to work other direction. So I'm set to 180 degrees. But sometimes there's a bug, so you need to always move it to see if it works or not. Or just switch on and off. Something strange happening. I don't know why they're doing. But anyways, just to show you exactly what's happening, let's just also increase the distance in between so we can only have few of them. And as you can see, my lights are being on. And I can go back. And as you might start seeing, my lights started to work. So like imagine you have a night scene and you want to have a racetrack there, then you can start testing this out by not only adding more lights and see how beautifully it will render with really nice lighting and shades around it, but at the same time you have also ability to increase the number of lights if you wanted to, and also be able to have really cool, decent visualization that comes with all these effective tools that comes with it. Some of you might perhaps encounter this issue while trying to spawn more, in this case, lamppost actors along this spline when you're trying to create a new, in this case, point. So just to demonstrate you the meaning of this issue, if I may just duplicate this new point and see what happens. As you just witnessed, the entire project just crashed. And the reason why is this happening? For some strange reason, this shouldn't be happening, but for some reason it's doing that. I don't know what could be the cause. Maybe, which I suspect the reason why it's doing that is because there are lots of actors being trying to be spawned when this specific point in the spline is being generated, because it has to sort of like add all this, check through all the arrays and add all these new actors into the spline, which they don't currently exist. And then hence when trying to do this, it crashes. While this may not happen all the time, depending how you are approaching this problem, but just to give you a little bit more insight on how to fix this while you're struggling with this kind of issue, it's basically start off with very simple. In this case, best case scenario, I think which will be the most wisest here is to create these two buttons just like we created in the previous parts, like when we're trying to generate the forest here. Use the same principle, but just in this case, you are going to bake amounts of, in this case, lamp posts being generated along the spline. So let me just select the spline and then extend it, and just then click again, bake it. And what you just have with left off is just this empty spline. So you can then use the spline to duplicate your points and just draw it like this. And then once you're happy, then you go back and again, generate it. And then you can do whatever functionality to do that comes with this whole part of this actor for each of these actors meshes here. So this is the solution that you can use for this given exercise. So for now, thank you so much. And it was a great pleasure to give you all the insights on how you can create your own PCG blueprints and test them out yourself, and also how you can work with PCG graph and as your first time working with PCG in general, and how you can achieve very cool results just by adding some of these elements and making sure they all work within the blueprint, which comes to working and creating your own tools essential for world building. Specifically for this exercise is where we're going to create a racetrack, and we're going to create a very simple racetrack which is going to be already pretty much ready for you to only place the assets that we have just created using all these tools, and then you can decorate it on your own terms. But I'll show you how to all do this in the next lesson, which will be the final chapter of this module, and I'm really excited to show you how we can do this all together. Thank you so much, and I'll see you in the next and the final chapter.